Hello YouTube, welcome back to Science While Gaming with me, Mr. S. Today we are talking about the other type of compounds that can be formed by elements joining together, that type being covalent compounds. Mostly we focus on today writing formulas and naming them. Naming covalent compounds is actually an even easier process than ionic compounds, which I covered in my last video. We are picking up pretty much right where the last video left off in terms of the game. Not that it matters really if you're super interested in that. If you're not, that's fine. If you are, very quickly, it's coming along. Big old plant here, keeping everybody alive. Still keeping with clean energy sources, water mills, geothermal. Few attacks. If you're familiar with the game, the idea is to, if you're not familiar with the game, the idea is to get off planet, survive. Random events occur, so during the course of my talking, I might get distracted by like an attack or giant insects that pop out of the ground, which happened during the last session. It happens. We deal with it. It is what it is. Anyway, so starting our discussion about covalent compounds. The major thing to think about with covalent compounds is how to identify them. So step one, of course, is going to be identifying a covalent compound. And identifying actually is fairly easy to do. You know you have a covalent compound when you have all nonmetals. There'll be no polyatomics, there'll be no ions involved at all, there'll be no metals involved at all. It'll 100% be all nonmetals. So as long as you can tell the difference between a metal and a nonmetal, which if you've learned your periodic table or paying attention to it even in the slightest, should be really easy to do. Should be. If you haven't been paying attention, if you haven't done your job and learned at least part of the periodic table, then it's gonna be a little tougher. So if you're struggling with that, my suggestion to you is to go back, watch some of the other videos that I've done talking about exactly those topics and do it, or talk to your teacher and cover it with them, or do any number of other things to actually get yourself up to where you need to be. Regardless, once you can identify that you have all nonmetals in your compound, which excellent, you should be able to do, and assuming you have is relatively easy. Now you have all nonmetals in there. Well, how do we name them? When we named ionic compounds, you had to write the name of the metal first. Obviously there's no metal here, so you can't do that. So what do you do instead? You write the name of the nonmetal first, and maybe it's better if I give you an example of a compound before we really get into it, so that way you can understand what we're discussing, what we're talking about, and actually be able to focus on that. Yeah, let's do that. So the best example for a molecular compound for made of just nonmetals is this right here. Right in here, it's water. You have known the formula of water probably your entire life, because every science class that you've ever taken has always talked about it. Because water is necessary to living, to all of the things that you want to do in life, to existence. So with water being so important, it's important to know what to call it, what it makes up. If you know water's formula, you know that it's H2O. And you should know it, one would hope. So let's draw a little H2O here, just so that way you can keep it in mind, and I'll refer back to it a couple of times. So we have H, and we'll give ourselves a little 2, and don't judge me, I'm a drawing. You see the tools I'm working with, I'm doing the best I can. H2, then we have O. That seems a little tall. So you have H2O. Now H2O is the chemical formula. This is true, and this is the thing that you've heard like your whole life. Everybody's talked about H2O. What they haven't talked about is the name. The name of water is not H2O, and it is known as water, but strictly speaking, as far as chemicals are concerned, and water, yes, believe it or not, is a chemical, it's named differently, so we need to be able to do that. The very first thing that you're going to want to do is identify your two elements that are involved. They're both going to be nonmetals. Even if one sometimes behaves like a metal, they're still gonna be nonmetals. And so when you have two nonmetals like you have here, you're gonna know that you have a covalent compound. You know that you're gonna be naming them in this pattern. The first thing you're gonna do is write the name of the first nonmetal. Here, the first nonmetal, hydrogen. Look it up on the periodic table. If you don't have it memorized, that's cool. You just have to be able to read the periodic table. I stress it a lot. It's a tool that's there for you to use. Definitely be able to do it. It's not a hard task. You just gotta actually get it done. But once you write the name of that first nonmetal, what are you going to do with it? That's what it becomes. The question becomes, what to do now? Well, the priority that we're going to do with covalent compounds is we are going to use a system of prefixes in order to show how many of each element are there. When we dealt with ionic compounds, you don't deal with how many of each element are there. You only deal with the charges in making a balanced compound. Here, because we're not dealing with charges, it's not a thing that we actually care about. What we care about is how many of each element. That's the concern. How many of these guys are here? So you need to know your prefixes. In a professional setting, this will be something you can look up, but if you're a professional in a science field, they're going to expect you to know at least the first 10 prefixes. And if you've done any geometry in your life, or if you've talked about shapes like ever, you should have a fairly decent understanding of the prefixes. The prefix for 1 is mono, 2 is di, 3 is tri, 4 is tetra, and then you have penta, hexa, hepta, octa, nona, and deca. Those are it. That's 10. That's what you need to know. Know those 10. There's no way around it. It's the kind of thing you really just kind of gotta memorize. Some things in chemistry, which you know is my focus, there are tips and tricks that I can teach you to make your life easier. Not for memorizing these. Know your prefixes. I don't know a mnemonic to give you. I'm sure there's one that exists. I was never taught one. I don't know one. I just had to learn it. And I did. It's not a hard thing to learn. Once you know your prefixes, oh, poor Annabelle is very tired, and so now she's wandering around from sadness. I know how that is. But once you know your prefixes, it becomes easy. So now we write the name of our first nonmetal, hydrogen, and then you write a prefix. Prefix is going on the front, indicating how many of those hydrogens you have. So here we have 2. From this 2 here, written lowercase is as a subscript, is what it's called, bottom right side of the hydrogen. So we have 2 hydrogens. Prefix for 2 is di, so we have dihydrogen. Now we're looking at the oxygen. Your second step is to write the name of the second nonmetal. Oh, excuse me, no metals in covalent compounds. That's the deal. So, writing the name of our second element that's there, the second nonmetal, you're going to end up with oxygen. But we need to indicate how many oxygens. So, we need a prefix. Now in this case, our prefix for 1 is mono. Just like this, M-O-N-O. But there's a little bit of a problem. That problem is that oxygen starts with an O. Hopefully you were aware of that, but it doesn't. So oxygen starting with an O, you would end up with something like this if you simply put the prefix attached to the oxygen. It would look like this. We don't want to do that. Whenever you have a prefix that ends in O or A, you don't want to attach that O or an A to the oxygen. You want to just drop one of the O's so you end up with monox and not monoox. And then just like with ionic compounds, you want to change the ending of your second nonmetal, the second thing you write, to IDE. So we don't write oxygen, right? We don't write monooxygen, we write monoxide because we're dropping this O. So mono and then oxide. So OXIDE would be the one oxygen indicated here. So your prefixes tell you how many of each have. The mono tells us we have 1 oxygen. And this system is what we use to name covalent compounds. Any covalent compound, anytime you have more than one nonmetal joined together, you're going to have this system. You will have a covalent compound. So that covalent compound needs to be named as that with those prefixes there. If you don't, then you don't know how many you have, you don't know what the deal is. It's necessary to be able to read those covalent compounds by using those prefixes. If you don't know them, that's a problem. So learn them. 100% of the time, you're gonna have to learn them, you're gonna have to know them. If you would like any practice, just like with the other video, feel free to drop me a question in the comments and I will be happy to tell you some compounds for you to name and have you focus on them and try to get them fixed and named, and then I'll correct you if you do them wrong. You could also ask your teachers. I'm sure they'd be more than happy to give you some extra practice for you to do, because practice is good for you. That's how you get good at stuff. Without practice, you're just gonna be trash at everything ever. And just like with some games, you've got to get good. There's no two ways about it. You just gotta get good at it. And that's it. That's how we do naming covalent compounds. Write the name of the first nonmetal, add the prefix to indicate how many. Write the name of the second nonmetal, change the ending to IDE, and then write your prefix to indicate how many you have from the formula. No two ways about it. There's no other way to do it. It's easy, it's simple, it's real quick. It's just a matter of practicing and doing it. Any questions? Drop me a line. You know where I'm at. Have a good day, YouTube. Enjoy yourself. Leave a comment. You know the drill. Bye-bye.